Okay, this is the second part of the inverse trig lesson. In this video, we are going to talk about composition of inverse trig functions. So review of inverse function is one more time. I'm going over this. F of g of x is equal to g of f of x is equal to x. Then f and g are inverse of each other. This fact we have used so many times in every single unit, and you are supposed to know also that inverse of each other, because many times they give you this, they don't say they are inverse, like they give you this fact and you are supposed to know that this mean they are inverse of each other. So be careful. You have to, not all the time everything is explicitly given to you. If they give you this, means it is inverse. So what happened that if we have a sine of sine inverse x, do we get the x back? Possibly. True. Cosine of cosine inverse, if you can read this is the inverse. Do you get x back? So we are not looking at this, that whenever they are defined, what that mean is, if inside works, then only outside works. So you have to know that what's the domain of inside. Domain of inside is -1 to 1. If this inside work, then outside work. If you recall, in the previous unit, we talked about f walks into g and then f of g of x. If f doesn't work, g will not work. So you have to think of that way, if the first one should work. In here, domain of cosine inverse is -1 and 1. Bear with me, I'm sorry. This is -1 and 1. This is also -1 and 1. Now, sine, domain of sine is all real number. So think about inside is -1 and 1. We don't have to worry about outside. So if this x is between -1 and 1, you will get the x back. Cosine is a good guy, all real number, but cosine inverse work only between -1 and 1. So this x, you will get it back only if x is between -1 and 1. Okay, so tangent. Domain of tangent inverse is all real numbers. So this is happy, happy, happy. First row is not a big problem. Okay, so the second row, notice that the second row, they are backward. Sine inverse is outside. So I'm putting a star here because this is the one where you have to be very careful. Following equations are only true where restricted domain. You have to think of restricted domain of sine, cosine, tangent. So remember, sine x is all real number. But what was the restricted domain for this so that it works? So that's where you have to talk about restricted domain. So recall that it was true only if it is this number x is between -pi over and pi over 2. This is restricted domain is 0 to pi. This restricted domain, now let's talk about restricted domain. Remember, domain of tangent is all real number. So then we don't have to worry about this. They both will work all the time. Tangent is not a big deal. It will work all the time. These four are the one we have to watch out for them. Again, these two are also not a big deal. These are the one you have to watch out for them. So let's practice with some problems on here. Okay, so tangent arctan -1. Well, what this means is, are we going to get the original one back? Possibly. So we remember, I mean, if you memorize this, you can say the answer is -1. But well, I don't know then. So let's always do the inside first. Tangent inverse -1 is, what's the angle? So the tangent is -1, which answer is -pi over 4. If you recall, in the previous lesson, we talked about this. So now do the outside. What is tangent of -pi over 4? You get the -1 back. So this is happy, happy, happy. You get the original one back. Remember, tangent is the only good guy in this case. Normally, the tangent is notorious because they have always asymptotes. Okay, back here, sine and sine inverse. So multiple choice question. One of the answer choice is sine 5 pi over 3. I mean, arc sine, they cancel each other, 5 pi over 3, but that's not the case. You have to look at those two outside. Check it out, this one. It has to be between this range. So I'm going to show you two different approach in this case. One is a long way, another is a shortcut. Long way is always you guarantee the answer. You always get the answer. So always in sine 5 pi over 3. What's this number? Sine 5 pi over 3. 5 pi over 3 is here. So that will be negative root 3 over 2. Now work outside. So sine inverse. Arc sine is the same as sine inverse. Negative root 3 over 2. Which means what's the angle so that sine is negative root 3 over 2. So that means I'm going backward, and remember we go negative. So what's that angle? Now in backward is negative pi over 3. That's the answer. Not you don't get 5 pi over 3 back. You do not get 5 pi over 3 back. Alternate approach. Alternate approach. You are at the same place, 5 pi over 3, but you have to look at backward, and you can say this is the same as negative pi over 3. You don't have to do all this work. If you understand one more time, 5 pi over 3 forward is 5 pi over 3, but tangent inverse, sine inverse is this side. So I go backward is the same as negative pi over 3. Long way, shortcut. It only works, shortcut works only if they match. So we are going to look at some functions where they don't match. They don't match. Okay, so let's check here. Cosine, arc cosine. Okay, you think the answer is pi. Possible. Let's check it out. So always do inside first. Cosine inverse pi. What's this number? Well, remember cosine inverse domain is negative 1 and 1. Is pi 314? Would it work? If inside does not work, that means outside does not work either. Undefined. Undefined. This is undefined because domain of cosine inverse is negative 1 and 1. Inside will not work. Outside will not work. Think of that. Okay, so a few more. Sine 2 pi over 3, sine 2 inverse 2 pi over 3. So shall we use a shortcut? Where is 2 pi over 3? 2 pi over 3 is here. Sine inverse is this. Sine is positive. Remember the height is positive. Sine is positive here. Out of this two quadrant, positive is here, not this. So what is that angle? Similar angle where you have the same height. Pi over 3. If you don't understand the shortcut, well, go ahead. Sine 2 pi over 3 is root 3 over 2, and then sine inverse root 3 over 2 is back to pi over 3. You got the same answer. Okay, if they match, you can try shortcut. One more time. Cosine negative pi over 3 is here. Cosine is x. X is a positive. Cosine inverse is this. So what would be the similar angle here where I still have a positive x value? Obviously, pi over 3. Alternate approach. Cosine is even function, which means negative, positive, same. Which means cosine inverse of cosine pi over 3, of course you will get pi over 3 back. So super cool, super easy. Now, this one. Sine, 5 pi over 4, 5 pi over 4, 1, 2, 3, 4, 5. 5 pi over 4 is here. Okay, sine is negative. 5 pi over 4, sine is negative. Sine inverse is this half of the circle. Where is a sine negative? Is this? What's that angle? Negative pi over 4. So this answer is negative pi over 4, not 5 pi over 4. Now what happens if you have some other numbers? So I'm going little sidetrack and explaining what if they do not match. What if they do not match? So giving you example. I'm clearing, write down on a side note somewhere. What will be if they do not match? Instead of cosine, this is a sine. What do you do here? Well, there is no shortcut. You have no way to match this. You have to do long way, which is sine of negative pi over 3. Sine of negative pi over 3 is negative root 3 over 2. Then go back. Cosine inverse of negative root 3 over 2. Cosine means x. Negative is this side. In cosine inverse is here. Negative root 3 over 2. What would be that angle? Which will be 5 pi over 6. So watch out this. If they do not have a matching function, you must do long way. Please pay attention for this kind of questions. Okay, so let's flip the paper and we look at these AP style questions. They are using that's very confusing from all those triangles, but remember, you are looking always bow tie, you are always making bow tie. So read carefully. QRS, results of terminal ray being reflected over the y-axis, determine which label point intersects the terminal ray of given angle. So let's make it theta. Can I say cosine theta is a x? So what would be the point? Which point it reflects to? That's asking for which label point this intersects. So clearly x is there. So this is point P. Let's say this is theta. Sine theta is negative y, which means which point I have to now remember y, negative y is R and S both. But sine inverse is this side. So the point is S. You cannot go on this side. Okay, so cosine theta is negative x. Negative x is, it's possible that you have a point Q and R, right? Both. But cosine inverse is this side. So this is referring to point Q. Tangent theta is negative y over x. Tangent is negative here and here, negative slope, right? Slope is negative, but tangent inverse is this side. So this is the point, which is point S. So this question is kind of reviewing all the properties and restricted domain of inverse trig functions. Now, you may refer to some of the homework problem which are given like this, and I would like to explain how to do this kind of question. These are AP style question. Typically free response question number 4. Okay, so how do we do? We have an inverse on both sides. What's the approach here? Okay, so what we have to do is evaluate first one side. What is cosine inverse 0? So go on the side. Cosine theta is a 0. What's the theta? Which is pi over 2. Then bring back here pi over 2. Sine inverse x. Your job, solve means find x. So now based on this is sine inverse. So can I say sine pi over 2 is x, which means x is a 1. Pay attention again. They are nice, simple, easy one, but slight complicated because you have both sides. So we call them solve equations using inverse trig. Okay, so let's take a look at example 8 here. Really cool problem. Cosine inverse negative half. So go on the side. Cosine theta is negative half. Cosine theta negative half, which is here. Cosine inverse is there. So what would be that angle? Large angle, right? And that point is 2 pi over 3. So can I say this is 2 pi over 3? 2 sine inverse x. You can't solve for x until you take care of this 2. So sine inverse x is equal to 2 pi over 3 divided by 2. So I can say times 1/2, which will give you pi over 3. Sine inverse x is pi over 3. X is equal to sine pi over 3, which is root 3 over 2. Okay, so give it a try. Pause the video here and try yourself this one. Okay, so sine theta is negative root 2 over 2, which means this is negative pi over 4. Know that sine inverse this side of the circle, medium angle. So this is negative pi over 4. Tangent inverse pi x. Again, to solve for this, you take the tangent on the other side. So tangent of negative pi over 4 equal to pi x. So back to the same place, but the tangent. So I have to look at the slope. So what this slope is? Negative 1 pi x. Solve for x, which is negative 1 over pi. Okay, so this one on this side, I like to use different color paints. Okay, so cosine inverse negative 1, which means again cosine theta is negative 1. Cosine theta negative 1 is here. Location is a pi. So this is pi. 3. Sine inverse x over 2. You must divide by 3. So sine inverse x over 2 is pi over 3, which means sine pi over 3 is equal to x over 2. Now, make sure you don't have a runaway train. You can't just keep equal to equal to equal to. So sine pi over 3 is root 3 over 2. So I don't have a lot of space. So I'm going to write down root 3 over 2 is equal to x over 2, which gives you x equal to root 3. Super cool problems, and make sure you know how to do them. Thank you so much.